Let's see this question. We want to find all roots of this polynomial function degree 3. Right, so we know because it's degree 3, so at the most, we can have 3 roots. So we may have 1, may have 2, may at the most have 3 roots. So we want to apply something called a rational root theorem. I got to back to my drawing pad. So we want to apply rational root theorem. So the theorem says all the roots of this function comes from the quotient of 2 members, from the quotient of the constant term. So in this case, the factors of constant term in the function divided by the factors of the leading coefficient. Well, in this case, the leading coefficient is 4. So if we list the factors of 18, the factors of 18 are 1, 2, 3, 6, 9, 18. And the factors of 4 are 1 and 2 and 4. So when we divide, so we see the quotient of these two, the factors, if we divide, so what do we have to do? We have to divide every one with 1. So just get itself. So let's say possible roots. Or we just do this once. We don't have to do this all the time. So possible roots. And we always have plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, plus minus 18. Then we use all those divided by the, oops, yeah, we are done with 1. So we divide by 2. Then we get a plus minus half, plus minus 1, which is the same as this one, but we don't really have to write it because we already have it. Then plus minus 3 over 2, plus minus 6 divided by 2, plus minus 3, we already have it. So then plus 9, plus minus 9 over 2. Then plus minus 18 divided by 2, which is 9, we have already. So now we divide, so 2, we have divided by 2, it's done. Now we divide by 4. So plus minus quarter, plus minus half, 2 divided by 4 is half, we have already. Then plus minus 3/4. Then plus minus 6 divided by 4, which is 3 over 2, we have already. Then 9 divided by 4, so plus minus 9 divided by 4. So the roots, so the roots of f is from here, for rational roots, real roots. We're not talking about complex roots. Right? But usually, do we really have to do this? Well, sometimes we do, but for practice purposes, usually we do not too. We just try the simplest, the easy ones. So for us, let's try plus minus 1. Okay, because it's degree 3, let's use a synthetic division. Synthetic division, I like to call short division. So we won't have to deal with the coefficients of every member. So we write 4, leading coefficient 4, negative 17, coefficient of x squared, negative 39, coefficient of x, then negative 18. So you see, this is in order. So I have a degree 3, degree 2, degree 1, then degree 0. Right? That's x raised by 0. So you sometimes will miss one term. So we're going to put a 0 to take the spot. Now what do? We're going to try 1. This 1 means we're going to try if x minus 1 is a factor. Right? So we're thinking is x minus 1, can this function be factored as one factor is x minus 1 or with some other factors? So put 1 here. Then first step, we pull this 4 down. Then we multiply 1 with 4. We get a 4 over here. Then plus those two numbers, we get negative 13. Then multiply 1 with negative 13. We put down here. We add those two numbers. We get negative 52. Right? 1 times negative 52 will be negative 52. And we add those two numbers, not 0. So we know 1 is not a root of this function. So then we try negative 1. Negative 1 means we're thinking if x plus 1 is a factor. Then negative 1 times 4, we get negative 4. We add those two, we get negative 21. Negative 1 times negative 21, we get a positive 21. We get positive 21. Add those two, we get negative 18. Negative 1 times negative 18, bingo, positive 18. Well, positive 18 plus negative 18, we get 0. So which means indeed, so this function can be written in a factored form. So x plus 1 times 4x squared, 4 comes from this guy, minus 21x coming from here, minus 18. All right, so we have a linear factor and a quadratic factor. So, well, quadratic, and usually we know how to factor it, right? We want to try, can we factor into two binomials? So we have 4x. We have x. So what do we think? We need to make negative 21x, or maybe let's use this one. Let's write this one. So we need to play with the factors of 4 and the factors of 18 again. So let's say we have 4 here, we have 1 here. So this means 4x, 1x. Then somehow we want to put the factors of 18 to be here and here. 1 is positive, 1 is negative, because we have negative 18. And to make the middle term to be negative 21. So think about 6, right? Negative 6 and the positive 3. Positive 3 times negative 6, negative 18. Then 4x times negative 6, we get negative 24x. 1x times 3, we get 3x. Bingo. Negative 24x plus 3x, that's negative 21x. So which means this one, now we do one step further, we can do x plus 1 factor to be 4x plus 3 comes from here. Then x minus 6 comes from here. All right, now it's easy to find the roots, right? So roots also called zeros, which means when the function value equals 0. So when this equals 0, and what do we have? We have these three factors, each one can be 0 by 0 property. And that means x plus 1 can be 0, 4x plus 3 can be 0, and x minus 6 can be 0. Solve each one, get x equals negative 1, x equals negative 3 over 4, x equals 6. So yes, we have 3 roots.